Hello everyone, and welcome to an overview of engineering. You can see the definition of engineering right here, the application of math and science principles to better and improve life. But another way that I like to think of it is that engineers use math and science principles to solve problems. That definition of solving problems is repeated here. So you can see an actual engineer is a person who is trained in and uses technical and scientific knowledge to solve practical problems. What we mean by practical problems are problems that have been justified by research and data that there is a need to be solved. Now you see these two websites right here. The one of the engineer's greatest achievements and Engineering Girl. This website right here in particular of the greatest achievements is one that you'll use in this Discover Engineering assignment. For the fields of engineering, there's what's called the Big Four. The Big Four are chemical, civil, electrical, and mechanical. Pretty much every single other discipline of engineering is derivative or comes from, is combined of these, or is an extension of one of these. So that means that all of the other fields of engineering are generally subcategories of the Big Four. So what do engineers do? Now, in general, there's all kinds of things that engineers do. But this just kind of says that you may research, develop, design, supervise, or manage. A big thing to notice is what you don't see is build. So engineers generally do not build. Okay? That may be something that you think happens a lot, but it is one of the biggest misconceptions that I see. You may help prototype, you may help test the prototype, but you're not out there building things. So for instance, on the new building for Career Tech that's being built, the engineers developed it, they researched, they designed it, they supervise it, they manage it, but as far as the actual construction, they are not the ones doing the construction. So if you see an engineer on the job site, those are usually the guys in hard hats and a button-up shirt. So research is one of those things. Engineers may take the basic scientific principles and take discovery and application of new knowledge that has commercial and economic value. They may develop existing or invent new products. They discover truths about a subject. Okay? Generally, what that means is that scientists will come up with a cutting edge new findings. But the engineers are important in employing these ideas and in the application of new knowledge. And some pretty big deals are how can it be used in the real world. Developing and existing products basically is our innovation, or they invent things. In the development is when the engineers construct things. So this may be building. But notice that what's important is that you see testing of scale models, pilot models, and experimental models. So what that means is they're testing new things. They're not building final products. A lot of times engineers will hand off the plans they've created for someone else to build final products. Another thing to notice is not dealing exclusively with new discoveries, but using these principles and processes to perform new or unusual functions. So that's kind of a big deal. Engineers can do a lot of searches as well. So searching the library, literature, and patents for existing ideas are important. Engineers are also heavily involved in design. One big deal is anticipating the problems that users may create. That's something you want to design for, and that involves research. The reason you want to do this is to help prevent these errors, these accidents, this dissatisfaction from your users. You want to make it easy and you may even think intuitive to use. You have to understand the capabilities of machines. You have to have this mastery of basic principles in order to apply this. Engineers do a lot of supervising. So you may have a design engineer who has designed it, done the research, drawn up the plans, and sent it to a manufacturer where the manufacturers actually make it. Now, notice the engineer is not making the final product. The engineer is supervising the assembly of the object to make sure that specifications are followed. They work closely with the technicians, the mechanics, the laborers. Those are the people that actually are building it. They have to make sure that they estimate and bid for jobs. What that means is you are telling people how much you can make something for. And so these people need the knowledge of materials, how stuff's made, and these general physical principles, because it's important to be able to estimate the time and cost to accomplish these tasks. Production and construction is another important part. Once again, you're going to notice that they're not doing the buildings themselves. You have a project engineer who helps supervise other engineers. They're important in making sure that the project's going along for the timeline. Things like preparing schedules for the production or construction. So not only do they need the knowledge of engineering principles to know what everybody else is doing, they need the visualization skills to see how it all fits together. Operations and plant engineers may be responsible for maintenance of the building equipment, grounds, and utilities. Once again, that does not mean that they're the people going out and actually doing the maintenance. They're not repairing the maintenance systems, okay? They may do various routine tasks, but also setting up and regulating complex automated machinery is another thing that they may do. They need a wide knowledge of several different branches because all these different branches of engineering are put together to make a facility. Another important thing that they have to be able to do is to be able to do cost of operating. So operating costs with different conditions. You need to be able to have knowledge of the machinery so that you can set the schedules for them to make sure that they're being used at their maximum efficiency. They need to know when to bring in new equipment, when to send old equipment out. And it's ultimately important to be able to work with people because you'll be managing people. You have to be able to work with machines because you have to manage the entire operation of the plant. And you have to know what you can expect from your facility. Sales is actually a thing that engineers do as well. Think about this. If you're the CEO of a company and you have a complex piece of machinery, of software, of whatever it is, if the salesperson is an engineer and has an engineering background, then they're going to have a much better technical knowledge and ability to tell you what's going on than just your run-of-the-mill salesman. So it's not only being able to talk the language of the people you're selling to, but you have to be able to answer these technical questions. Showing you're familiar with operations of plants and knowing how the product will fit in. You have to be able to show the economics involved. And once again, prices and economics are a big deal here. You have to know that when there's nothing available, all right, there's a need for research and development. Management. So an interesting thing right here is where surveys are showing that corporate leaders have a background in engineering and science. And the reason for this is because of this problem-solving process that we're going to go through this year and being able to apply that. So the type of things that they're doing is making decisions involving equipment, labor force, and once again, finances. Also in management, there's the business side that engineers might have to work harder to develop. But you need to be able to look at these long-range effects of policy decisions. And once again, here's the word of financial. Finances are a big deal. The cost of something is a big deal. You may have designed the best product in the world, but if it costs too much, then nobody will purchase it. And so with that, that is our final slide for just an overview of what engineering is and what engineers may do.